All right, so for today's lesson, we're going to continue graphing sine and cosine functions, but we're going to talk about the period. We're going to add in the final transformation, which is the b, which is going to change our period. So let's start with some warm-ups, what we should already know from last week. All right, so we want to graph 2 times sine of x plus pi. So again, the 2 is the amplitude, all right, which is going to affect our range or our maximums and our minimums. Okay, so it's going to be 2 above the midline. Since k is 0 here, the midline is going to be 0. This pi right here is the h. Okay, it's plus pi, so it's being shifted to the left pi units. Okay, and so to sketch this graph, all right, we just want to kind of make a table of values here. So if I plug in negative pi, okay, what do I get? So if I plug in negative pi, right, negative pi plus pi is 0. Okay, sine of 0 is 0. And so 0 times 2 is 0. Okay. And if I plug in negative pi halves, okay, I get sine of pi halves, which is 1. 1 times 2 is 2. If I plug in 0, okay, I get sine of pi. Sine of pi is 0. Okay, if I plug in positive pi halves, and now I'm at 3 pi halves. Sine of 3 pi halves is a negative 1. Negative 1 times 2 is negative 2. And if I go all the way to pi, again, I'm at 2 pi. Sine of 2 pi is 0. So that's 0. So we have one full cycle here, okay, for the period from negative pi to pi. So we have 0 there. Negative pi halves is 2, 0, negative 2, and 0. So here is our function, right? So for one cycle from negative pi to pi, the graph looks like this. Okay, and so obviously we could continue the graph. 3 pi halves would be 2, 2 pi would be 0. Okay, over here, negative 3 pi halves would be negative 2, negative 2 pi would be 0. So we could obviously continue our graph like this. All right. All right, remember for the sine and cosine function, the period is 2 pi, okay, for the parent function. So until we introduce that b, which we're going to do today, right, the period's always going to be 2 pi. Next example, okay, is a cosine. Okay, so here we have an h and a k. Okay, the amplitude is 1. We're going to shift this pi halves units to the left, okay, and we're going to shift it up 3 units. Okay, so we are going to have a midline at 3. Okay, so our max will be 1 above that, and our min will be 1 below that. So our maximums are going to be at 4, our minimums are going to be at 2 for this graph. All right, so let's make our table of values again. Again, I always like to start my table of values at the point that's going to make that 0. So I'm going to start it at negative pi halves. Okay. And so I get cosine of 0, which is 1. 1 plus 3 is 4. So then if I go to 0, cosine of pi halves is 0. 0 plus 3 is 3. Go to positive pi halves. So now I'm at cosine of pi, which is negative 1. Negative 1 plus 3 is 2. And then I go to pi. I end up at cosine of 3 pi halves, which is 0. 0 plus 3 is 3. And if I go to 3 pi halves, I'm at cosine of 2 pi, which is 1. 1 plus 3 is 4. All right, so if we plot these points, oops, let me switch here. So we're at negative pi halves 4, 0, 3, pi halves is 2, pi is 3, 3 pi halves is 4. So you can see for this one cycle of the period from negative pi halves to 3 pi halves, there it is. So we know at 2 pi, it's going to come back down towards 3, towards the midline again. All right, we keep going this way. And that's our graph. All right, you can see that the midline is at 3, right? The amplitude is 1. Okay, and so there you go. All right, so now we want to type in the equation that's going to pass through these points. So a good strategy for these types, okay, it says write a sine and a cosine function. So a good strategy is start with the parent function. All right, and so you can see here that the midline, okay, is going to be at 1. So we want to add a 1 to that. Okay, and then we want to shift this over, okay, the midline is going to be over at pi 4, so I want to shift that to the right pi 4, so we go minus pi 4. Now all I need to do is increase my amplitude, okay, up to 2. And there's my sine function. So I just took my parent function, okay, and I noticed what the midline should be, so I adjusted my k. All right, then you could either just shift the max point over, a midline point over, or min over till it hits it, okay, and do that. That's what I did. Now we got to do a cosine one. All right, so let's do the same thing with the cosine. So y equals, we know the amplitude is going to be 2, so let's go ahead and type that in, save us some time. Okay, and we also know that our midline will be at 1, so our k is 1. Okay, and now, so how far do I have to shift it? All right, so I could shift, so now let's look at the max. So I want to shift the max over here, okay, so it's at 0, and I want to come over to 3 pi 4, so I got to shift it to the right, okay, 3 pi 4, or I could go all the way to the left, negative 5 pi 4, or to the left 5 pi 4. So either one will work here, so let's just go to the right 3 pi 4, so minus 3 pi 4, and now you can see that it matches up, and we're good to go. All right, so now last warm up, okay, is identifying key features of a graph. All right, so what is the amplitude? So given the graph, okay, what's the amplitude? Normally, if it was the equation, we would just look for the A, right? Here, so you got to kind of identify the midline. Okay, the midline here is at -2, and so what's the amplitude going to be? It's going to go up to 1, so that difference is 3. All right, so we have this amplitude right here is 3. Right? And if you did it towards the min, you'd get the same thing from -2 to -5. That's 3. So my amplitude, okay, is 3. What is my midline? Well, you can see my midline is y equals -2. All right, so our k, and if we had to write the equation, that's when our k would be -2. Okay, the domain, okay, is all real numbers. Our range, okay, our minimum is -5, our maximum is 1. So those are going to be brackets, okay, -5, comma 1. Okay. Our maximums, okay, are every 2 pi. Okay, we hit a maximum. It starts at 0, all right, and the maximum is at 1. So again, how do you write that? So it's just going to be 2 pi k, comma 1, right, where k is an element of the integers. What happened? Well, I can't type in the word integers. Is it in math type? Well, I'm just going to verbalize it then since I can't type it in. okay, where k is an element of the integers. Okay, our minimums, okay, first one's at pi. Pi plus 2 pi k, comma, -5. Same thing, where k is an element of the integers. Again, I can't type in the word integers. Again, remember it's plus 2 pi k, okay, because the period is 2 pi. So it repeats, the minimum is going to repeat every 2 pi. All right, and then the period here is just 2 pi. All right, and again, for any sine and cosine, okay, the period is 2 pi when there is no b. But again, here you could just tell the period from, you could go from max to max, okay, that distance is 2 pi, right? You could go from minimum to minimum, okay, that distance is 2 pi. So you just got to complete one cycle, right? And that the length of that cycle is the period. All right, so here is the trig function, the sine and cosine function with all the transformations in it. Okay, so we've studied a, h, and k already. What we're going to focus on today here is this b. Okay, how does this b affect our period? Okay, is what we're going to focus on here. And if you guys can write this down in your notes, this whole slide, write down your notes, but this is going to be very important for today. The period is 2 pi over the absolute value of b. And in fact, today we're just going to always keep b positive. Okay, when b is negative, it's a reflection over the y-axis. So we're just going to keep it positive today, so we don't have to worry about that. All right, so here is the parent function of sine of x, and I got a b in there, so our slider is going to affect right here the b. So if I make b 1/2, okay, what happened to the period? Okay, so let's put it back at 1. So here's our normal one. Our period is 2 pi, right? From 0 to 2 pi is one cycle, all right? And if I make b 1/2, okay, now 0 to 2 pi is a half a cycle. All right, so the full cycle is from 0 to 4 pi. So now my period would be 4 pi. And what if I make b bigger than 1? Okay, what if I make b 2? Okay, now that period, that full cycle, only lasts for the length of pi. Now we cut the period down in half. It's fast, it's twice as fast. The period is twice as fast, right? And so every time I make b bigger, the period gets smaller and smaller. Right? It's easy to see at the multiples of 4. Okay, so now the period is pi halves. When b is 4, the period is pi halves. Okay, so b is going to, the bigger the b, okay, it speeds up the period. The shorter the cycle length is, the period is. So let's go ahead and look at the next slide. All right, so it says use the previous slide to answer the following questions. Okay, and so when b is 0.5, what is the period? Okay, so when b is 0.5, what is the period? All right, so let's go back. All right, make b 0.5, and I believe we already talked about this. The period was 4 pi. Okay, so you can see 4 pi. Okay, when b is 1, well, that's just the parent function, so we know that's 2 pi. Okay, when b was 2, all right, let's go back. Let's make b 2. Take a quick look at that again. When b is 2, okay, now the period is pi units long. So this takes pi units to complete one cycle. And then what if it's 4? Okay, if b is 4, now we see that it completes in pi halves. And if b was 8, okay, now you can see that it completes the cycle in pi fourths. Okay, so we could type those in. Pi halves when b is 4, okay, and pi fourths, and b is 8. Okay, so how does b affect the period? When is the period shorter than 2 pi? When is the period longer than 2 pi? The period is shorter than 2 pi when b is bigger than 1. Right, so all these, right, for when b is 2, 4, 8, so anything bigger than 1, when b is greater than 1, right, the period is shorter than 2 pi. Right, when is it longer than 2 pi? When b is less than 1. Okay, when b is between 0 and 1, okay, not 0, not including 0, okay, but greater than 0 and less than 1, then it is longer than 2 pi. All right, and so got some stuff here for your notes, okay? So the sine function with all the transformations is written like that, cosine the same way, okay? Notice that the b is written as a factor and is not being distributed, okay, with x minus h. So it's b then times x minus h. So b is a factor, x minus h is a factor. They did not multiply them together to get bx minus bh, okay? They left it in factored form here. All right, so we could correctly identify the b and the h. It has to be in factored form. So if you ever see it written differently, okay, where the b has already been distributed, then you have to factor out the b, okay, so you could correctly identify b and h. All right, and then for your notes, this was on the other form as well. To identify the period of a sine and cosine from the equation of the function, you use the formula 2 pi divided by the absolute value of b. Okay, to identify the period of sine and cosine from the equation of the function, you use this formula. Okay, you should have already written that down from the previous slide. All right, where's the 2 pi coming from? It's coming from, that's the period of our parent function. All right, so this formula is only good for sine and cosine functions, or any function that has a parent function has a period of 2 pi. Like we're going to learn about tangent in our next class, the tangent has a period of pi, and so this formula would not work, okay, for tangent. It's only going to work for sine and cosine. All right, so now I want you guys to go ahead and identify b, h, and the period, okay, based on these equations. So no graph, okay, just the equation of the function. All right, so you got to make sure it's in the correct form, which this one is 2x, h is, so b is 2, h is 0. So what's that going to do to my period? My period is 2 pi over b. If b is 2, that means my period is just pi. All right, now this one here, okay, cosine of negative cosine, that doesn't affect anything. That just means my amplitude, okay, is still 1, but it's been reflected, okay, across the k, right? My b is 1/2 and my h is pi halves. So b is 1/2 and h is pi halves. And so what's my period? My period will be 2 pi divided by 1/2, so that will be 4 pi. All right, this one here, 3 is the amplitude, doesn't affect my period. 4 is the b, and h is pi, so this is written in the correct form. And so my period would be pi halves, right? 2b divided by 4, so pi halves. And then now for this one, okay, this is what I'm talking about. Sometimes we'll see cosine and sine function written like this. Here you can see that it's not in the right form. Okay, b is not factored out. Okay, so I need to factor out that I need no number to be in front of the x there. So I need to factor out that 2. And so if I did that, okay, I would get cosine of 2 times x minus 2 pi. All right, so based off of that, okay, my b is 2 and my h is 2 pi. All right, and so if my b is 2, then my period is just pi. All right. All right, now we want you to try, so I need to type in the sine function that passes through this. So again, I'm going to just type in the parent function. All right, so you could see that's not right. I got to shift that up, right? I can see my midline's going to be at 2. I want to shift that up to, so my K is going to be 2. Looks like my amplitude's good. I just want to move my max, okay, to the left. What is that? 3 pi 4s. So pi, yeah, 3 pi 4s, right? Or I can move to the right. It looks like if I move it to the right 1/2, is that gonna work? Okay, let's try it. I don't think it will. Let's see if I go minus pi halves, it might. Oh, no, it's not the right. It's not on the right thing. I didn't go far enough. Okay, so let's go back here and let's try 3 pi 4s. And what did I do? All right, so that. Okay, get back to my parent function here. Oops. Hey guys, there we go. So what do I want? I want to move, okay, this back. Okay, if I move this back, okay, pi halves, okay, and is that going to work? Okay, and if not, why not? Maybe I need to affect my period is not right. Okay, so I think that's what's going on right now is my period is not correct. All right, so what's my period need to be? My period, okay, if you look here from min to min, okay, how big is my period? Okay, on this graph here. We'll go back to this, okay, so my period is going to be pi. Okay, so I gotta fix this. Okay, so this is that's why I can't get my shifting to work because my B is not right. Okay, now I got the period dialed in. Okay, now I just got to shift this back. Okay, pi halves. There we go. All right, so that period really was messing with me there because I didn't take the time to find the period first. All right, so I was trying to shift things left and right. All right, and then some points would line up, but the other ones wouldn't because now the cycle is shorter. So I had to adjust for the cycle, the period first, and then my shifting. Okay. So now let's do this again. So it's pretty much the same exact points here, but now they want us to do a cosine function. So again, we know cosine of x, okay, plus 2. Okay, again, my period, I got to adjust my period. Okay, so if my period is pi, I need my b to be 2. And now it looks like I'm going to the left. Okay, pi fourths. So I want to go plus pi fourths. And now we're dialed in. So much easier when we took care of the b. Okay, so that's a good thing to take note of, right? Is you want to figure out your period and then your shift. All right, another one. So now it says, right, 2 different sine functions. Okay, 2 different sine functions that pass through the given points. Okay. So what are those going to be? So let's just go ahead and start with our parent function. Y equals sine of x. Okay, obviously my amplitude is not big enough. I need to make my amplitude, it looks like 3. There we go. All right, and then let's identify our period. Okay, so it looks like our period is going to be stretched out. It's going to be 4 pi, it looks like. Okay, from negative 2 pi to 2 pi. That's 4 pi. So that means my b is going to be a half. Okay, so my b is a half. And now let's see what that did. Let's pull the graph back up. Okay, and now it looks like I just need to move this min, okay, to the left 2 pi or to the right 2 pi. So at this point, it doesn't matter if I go plus or minus 2 pi. I'm going to end up in the right spot. Okay, let's make, obviously, so we could do another easy one, which would be the same thing, which is minus 2 pi, but let's try making our a negative. How is that going to affect? So I know 1/2, okay. Now there's no shift, okay. Just reflecting it did the trick. I didn't need to shift it. I could just reflected it up and down. Okay. Now from scratch, I want you to sketch, okay, this function. So what is the period? Okay, so the period here, okay, our period is 2 pi over b. So b is 4. So 2 pi over 4. So my period is pi halves. Okay, so I don't know why I wrote 4. Pi halves. All right, so it's going to complete that cycle, okay, from 0 to pi halves. It's going to complete one cycle. All right, so if I make my table of values, at what points do I want to plug in? So let's plug in 0. So cosine of 0 is 1. 1 times 2 is 2. 2 minus 2 is 0. Well, plug in when my period ends, right? So I want to plug in pi halves. To plug in pi halves, right? 4 times pi halves is 2 pi. So again, cosine of 2 pi is 1. So I'm going to get the same thing there. So halfway in between 0 and 2 pi is pi fourths. Okay, halfway between 0 and pi halves is pi fourths. If I plugged in pi fourths, okay, I would just get cosine of pi, all right, which is -1, excuse me, and then so I get -2. So I get -4 here. No, I should get -4, and then halfway between 0 and pi fourths is pi eighths. So if I plugged in pi eighths, I'd get cosine of pi halves, which is 0. So 0 times 2 is 2. Okay, and then halfway between pi fourths and pi halves is 3 pi eighths. And if I plug that in, I get 3 pi halves. Cosine of 3 pi halves is 0, so that's -2. So these are the points that I want to graph right here. 0, 0. And let me actually just go back to using this. So 0, 0. Pi eighths is -2. So pi eighths is right in between 0 and pi fourths. Pi fourths is -4. 3 pi eighths is -2. And pi halves is 0. All right, so you're going to get this graph right here for one cycle of the period. Okay, and then obviously we can just repeat that pattern. Okay. And you could come back this way as well. And so that's going to be our graph. You can graph as many cycles as you want. I'm going to stop right there. All right, so now we have, last one here, we have sine of pi halves, sorry, excuse me, I can't read, sine of 1/2 times x minus pi. All right, so here our b is 1/2, so what is my period going to be? Okay, my period, right, is 2 pi divided by 1/2. So my period is 4 pi. All right, so when I go to pick my values here, okay, I want to pick, again, I like to pick what's going to make this, okay, 0 in here. So I could go with pi, and then 4 pi later would be 5 pi. All right, halfway between that would be 3 pi. All right, halfway between pi and 3 pi is 2 pi. 4 pi. So if I graph this, I mean, 5 pi is not going to be on my graph right now, but I'll be able to backtrack a little bit here, okay? And so if I plugged in pi again, I get 0, okay? Sine of 0 is 0. Okay, plug in 2 pi, I get 2 pi minus pi is pi, and then half of that. Okay, so sine of pi halves is 1. Plug in 3 pi, I get 2 pi, so I'm at sine of pi, which is 0. Plug in 4. Okay, 4 minus pi is 3 pi. 3 pi halves, sine of 3 pi halves is -1. Plug in 5 pi, I get 4 pi, so sine of 2 pi is 0. Okay, and so you see right there, so we got pi, 2 pi is 1, at 3 pi is 0, at 4 pi is -1. So if we were to plug in 0, it would be at -1. You kind of just see the whole graph here. Okay. So how am I picking what x values to plug in? Again, I like to always start at what makes that, it's going to make it 0, and then you go from that point and you just know how big the period is, and then you cut that in half, and then you cut that in half, right? And you're just working your quarters so you know you're hitting all the key points. All right, hopefully that helps. If you have any questions, please come to intervention.